So now we're going to go into proving identities, and this will be the first video out of 3. So why do we have trig identities? With trigonometry, there's a lot of graphs that if you graph them, they are identical. And so it has the same root word as identities. So here we go, we have cosine of 2x there. And I'm going to graph another thing here. Cosine squared of x minus sine squared of x. And lo and behold, there's magic here. If I stop and then bring this back again, they happen to be the exact same graph. And so this is an identity here we're going to go over later. Cosine of 2 times an angle is the same as cosine squared of the angle minus sine squared of the angle. And so there are a lot of times when this will pop up, and it's actually easier if you just rewrite it like that. So, without further ado, we are going to look at a few examples. So, my first example here. We are going to show that tangent of x plus cotangent of x is the same as secant of x cosecant of x. So this is very similar to simplifying, except in this case, they tell us where we should end up. And so there are a few rules that you can always kind of go with to help guide you through this. But in general, identities are really difficult because sometimes you have no idea where to go. So, number 1, or first thing you should always try, rewrite in terms of sine or cosine. Now that we should already know. Another thing is pick the more difficult side. So in this case, when I look at this, I actually am thinking that the left side is more difficult, and the reason is if you're adding functions together and they're fractions, you have to think about common denominators. So I'm going to rewrite the left side, the more difficult side, in terms of sine and cosine. Let's write this sine of x all over cosine of x plus, and the reciprocal. Alright, and here's the thing about identities. From this alone, I should be able to rearrange it and simplify it until I get this on the right side. So, one thing we always try to do is combine fractions together. And so, with this, I'm going to multiply by sine over sine, because on the left side, the denominator needs a sign below. And similarly, on the right side, we have cosine of x all over cosine of x. Alright, so on the left side, you can rewrite this as sine squared of x, sine times sine. On the right side, plus cosine squared of x. And since we have the same denominator on both fractions, we can now write this all over sine of x, cosine of x. Okay. Now, after that, we have to remember that sine squared plus cosine squared is 1. So this would be 1 all over sine of x, cosine of x. Okay, so now I'm thinking over here, this is secant and cosecant. They are related to sine and cosine because they're the reciprocals. If I broke this into 2 fractions and put it 1 over sine, 1 over cosine, 1 over sine is cosecant of x. 1 over cosine is secant of x. And because multiplication it's called commutative, you can flip them around. It doesn't matter which way you multiply them. This is what we had hoped to prove. So we started on the most complicated side. We rewrote things in terms of sine and cosine. And then we did what we normally would do when we're simplifying. We combine fractions, we find common denominators, and we were able to rewrite it as secant, cosecant. So I'm going to give you guys an identity, and I'd like you guys to try this now. We're going to do 1 over secant x minus 1 plus 1 over secant x plus 1. You need to show that this is the same as 2 cotangent of x cosecant of x. And at this point, you should pause the movie. You should try it yourself. Okay, so first step here, choose the more complicated side. I'm going to do the left side. And I'm going to have to multiply the left side by what it would take to get to the common denominator. In this case, I have secant of x minus 1. I need secant of x plus 1. So I multiply by secant x plus 1 on top and on bottom. And similarly over here, do the same. Secant of x minus 1 on top and on bottom. And you might be seeing that this is kind of familiar from before, because on the bottom you have that plus minus pattern, which is the difference of squares. But first, let's do the top here. 1 times this is just going to be secant x plus 1. And I'm drawing a line all the way across because it is over the same denominator. We'll just make one big fraction. And then when we distribute this, it's going to be plus secant x minus 1. Okay, now after that, you might already think, well, these plus and minus 1s will cancel. Before we keep going, though, let's rewrite the bottom. Secant of x plus 1, secant of x minus 1. All right, if you have secant x plus secant x, you can call that 2 secant x. And then on the bottom here, we have a difference of squares. And so this will turn out to be secant squared x minus 1. And now I'm seeing a secant squared. And if you see that, you should be thinking maybe this is the Pythagorean identity. If you remember, it's tangent squared of x plus 1 equals secant squared of x. Because if I do sine squared plus cosine squared equals 1, if I want secant squared, I have to divide everything by sine. Sorry, not by sine. We have to divide by cosine squared everywhere. And so we'll get 1 here, we'll get tangent there. This is what we're going to use. Now, if I subtract a 1 to both sides, it's going to be tan squared equals secant squared minus 1. So instead of secant squared minus 1, this is going to be the same as 2 secant x all over tan squared of x. Now we're getting really close. If you look back at the original thing, we already have the 2. And now we should be able to change the secant tan squared into a cotangent cosecant. So we're going to use the next idea that we had, is rewrite everything in terms of sine and cosine. So if I write this, it'll be 2. And I'm going to switch the tan squared so that it's actually cotangent squared x, so there's no more fraction. And then secant, I'm going to write 1 over cosine. And I'm just going to keep going here. I know cotangent is cosine squared over x, and there's a sine squared underneath there, and there's still a 1 over cosine x. So now you can see that there's 2 cosines on top, there's a cosine on bottom. So this is going to turn out to be 1 over, sorry, had to think there for a second. When our cosines cancel, we have 1 cosine on top, and we have 2 sines squared, sine squared on bottom. Now I'm just looking back here because I want a cotangent and I want a cosecant. If I was to rewrite this, I split up the sine squared, I put 1 sine all by itself, and here is my cotangent, here is my cosecant. So there were a few more steps there, but now we have finally proven that it is 2 cotangent and cosecant x. So before I go, guys, we already have the answer. And so the thing you should keep in mind, this is very philosophical and deep. It's not the end point, it's the journey. When you're doing these, the important point is that you're able to show every step by step how to get there to the end, because you already know the answer.